After I lost you, I lost my shoes. Lost everything that made me feel new. What do I do to kill this flu? Calculus FRQs to cure these COVID blues. Hey, what's up, everybody? Welcome back to Math Time. I'm your host, Mr. Quirk, and I finally put together these answers to this solution, the solution key to these FRQs that I gave you last Friday. So if you haven't finished them by now, you need to finish them and then go over this video. I'm going to try to rip through this as fast as I can and not make it an hour long like the last one. Also, I'll post this answer key as a PDF so you can look over just the answers. But if you want me to kind of help you talk you through it, the first question that I gave you on this assignment last Friday was from 1998, and I picked this one because if you go to Free Response BC Calculus questions, it's the oldest test that they have available on there. So I was like, let's look at this one. Now, what was different about this on the actual AP exam in 1998 was they wanted you to draw the slope field. So you can kind of tell that the font here, show the work to give, is a little different than the actual test. Consider the differential equation font. So I changed the question from draw the slope field to show the work to give the slope. And I think because on this year's AP exam, there's most likely no way they're going to ask you to draw the slope field. Usually you would do that in your AP exam, your response booklet. And you're not going to really have a response booklet. You're going to do stuff on paper, and then you're going to like take a picture and upload it. Unless you want to try to type your answers online, that's an option. But most people are probably going to write their answers out by hand. So what is the slope at -1/3? You're plugging -1/3 into the equation. -1 times 3 over 2 is -3/2. What's the slope at 1/2? The slope at 1/2 is 1 times 2 divided by 2, which is 1. So on the AP exam in 2000 or 1998, you would have had to draw a slope at this point of 1, right? Which would mean like up 1 over 1. So you would draw it in like that, and then you would like delete part of it. So you would actually have to have drawn it, and there were 9 points here, not just 2 on this question originally. So I just thought, well, I practiced having you find the slope. It was the only question I really had to change from all the others on here. So now we get to the fun parts. Part B, use Euler's method. So you start at the point 0.03. They tell you the steps are 0.1 for delta x. And remember, Euler's method is where you do slope times delta x. And slope times delta x gives you delta y, change in y. How are you getting this dy dx? How are you getting the slope? That comes from the differential equation that's at the top of the page, okay? The one that we just used in part A, which was x times y divided by 2. So for the first point, you got 0 times 3 over 2 times 0.1. So what is 3 divided by 2? That's 1.5. Oh, I'm sorry. But times 0, right, is 0. And 0 times 0.1 is 0. So 3 plus 0 gives you 3. So you take your y coordinate, you add your delta y, that gives you a new y. So it turns out our new y is the same as the old y. It doesn't happen every time, but it happens here. And so then in step 2, right, and you're going to need 2 steps here because they tell you the step size, delta x is 0.1, and you want to go from 0 to 0.2. So you're going to go 0 plus delta x gives me 0.1, and then 0.1 plus delta x gives me 0.2. So that's how it's going to take 2 lines in this Euler's method. And they do want you to show the work. So if you just have the answer, you would either get no points or you'd only get 1 out of the 2 points, because it does say in the answer key, use shows Euler's equations or table. It says that in the answer key. So you then have 0.1 is your new x times 3 divided by 2. And this is kind of tricky because there's no calculator here. You haven't had to do this kind of math like ever, right? You've had a calculator since like kindergarten. So maybe the best way to do this is I would take 3 divided by 2 and get 1.5. And then all 0.1 does is move the decimal over, so it's 0.15. And then you're going to multiply by 0.1 again, which makes it 0.015. That's kind of tricky. If there's no calculator, now this year you can have a calculator sitting right next to you. You can have a calculator. So there you go. 3.015 is f of 0.2. And now I've talked about this with each of you guys in the classes that we've had this week using Google Meet. Solving the differential equation that involves dividing by y. And I've numbered it here with the little black number ones, 1, 1, 1, 1, 1, because those are the points. So the first question was worth 1 point. The second question was worth 2 points, showing the equations and the answer. And then this question was worth 6 points. And the very first step, showing the separation of variables, moving the y to the left and the dx to the right, that's worth 1 point. The issue is if you don't do that step, then you get no points at all. And every single differential equation, guys, I'm telling you, every single differential equation, on every single differential equation that you could possibly solve on the AP exam, the first step is going to be separate the variables. And they want to see you separating the variables. They want to see an equation where the variables are, right, x's and y's. So undo. So I showed a lot of extra steps here that you wouldn't necessarily have to write. Technically, you'd probably just go from there to there, and then maybe to there. I just wrote that first step so you can see the separation of variables. You also got a point for integrating each side. Whoops, sorry. What the heck, Martian? So it was 1 point for the ln of the absolute value of y and 1 point for the 1/4 x squared plus c. And then what I'm recommending you guys do is solve it for y. Before you find c, solve it for y. So you plug in, so you don't plug in the point yet. If you look at their answer key in 1998, they actually plugged in the point here. And I think it makes it look way more confusing because you end up with, the c is the ln of 3, and it's just more complicated. So to solve it for y, you loop-de-loop it. That's what the green little arrows are for here, loop-de-loops. So it's y equals, you take it out of log form, put it in exponential form. And now this plus c you can write out front as c times e, okay, because there's a property of exponents. So we talked about this in our Google Meets classes, where I can take this plus c and move it out front. And then at this 0.03, I plug in 3 for y, I plug in 0 for x. And do the math, c is 3. So I got this equation. So that was 1 point as well to get the solution to the differential equation. It was also 1 point down here to solve it for y. Sorry, this was 1 point for solving it for y. There was a solution to the differential equation. Then you got 1 point for c. That's what this was finding c, if you could find c. And now they ask you then to use the solution to find f of 0.2. So again, I have a differential equation. When I integrate differential equation, I get y equals the equation whose derivative would be dy dx. And so now that I have that equation, I can plug in 0.2 and evaluate the function at 0.2. And you notice here, without a calculator, it's 3 times e to the 0.1. Back in 1998, you could use a calculator on any question. They didn't have that like sorting out questions business because they have the answer on the answer key with the decimal as well. You wouldn't have to have the decimal. You just leave it. Matter of fact, you can just stop right here. Right? That is the answer. I don't think you have to simplify it at all. Okay. So that was question number 4 from 1998. Okay. Example 2 on this set that I gave you last week was from 2009, question 4. And I picked this one again because it was a differential equation. And it also involved having a y in the denominator, but that comes later. Part A was Euler's method. So that's why I thought this was good. Since we just did Euler's method last week, I was like, okay, these first 2 problems both use Euler's method. So using the steps there, you get, Euler's method is 4.25. I noticed my finger, I must have erased part of it. It's 1. This is the delta x is 1/2. You got to get delta x. So unlike the last problem, they tell you to use steps of 0.1 on that 1998 problem. They tell you. So you never know what you're going to get. Life is like a box of AP calculus questions. You never know. It sucks. But no, delta x here, you have to find it. They tell you to use 2 steps, and they tell you to go from -1 to 0. So you could just think, well, it's going to be 1/2 and 1/2. But I wrote it out formally on the left. So there's the math there to get the 4.25. And then part B, which we've already gone over if you watched the other video that I made yesterday, the second degree Taylor polynomial. So the Taylor polynomial homework that I posted yesterday. If you haven't done that yet, then this answer is not going to make sense. But we've been over that before. There's no need to really talk about it again. Notice the first thing I wrote the formula for a Taylor polynomial with a second degree. So what I just put in that big blue circle, I would recommend writing on a piece of paper right now and keep it next to you and look at it every night before you go to bed. Keep it on your table, your nightstand or whatever. Again, you get to use your notes on this AP exam. They're not going to be, keeping that from you. The issue is you can't spend forever flipping through pages. So maybe have some highlights of things that are important before the time comes to have near. But that's the Taylor polynomial for this function f. They did tell you the second derivative is negative 12, but how do you know what the first derivative at negative 1 is? Again, that comes from the equation up there in green, the one with the green around it, right? So you have to use and we did it here, right? That right there is f prime of negative 1. So it's 4. The people that are paying attention are like, oh, well, yeah, I know. It's 4. Same 4 I had on part A. Oops. Same 4 I had on part A. Part C, boom. This is like the one that we just did from 1998, where you're going to have to first step separate the variables. So I took 2 steps to do that. And I showed lots of steps here with this problem. You can spend some time looking at this on your own. Pause the video and look at it. What the heck just happened? Martin? I don't know. Did I undo something? I noticed that there's no equation over here. This should be equals. I don't know what happened to the equal sign. I just erased it with my finger. First step is you have to the x squared. Then you move the 6 minus y over. You have to divide by 6 minus y. There was 1 point here for separation of variables. If you don't show this right here, this step, you have to show the equation with the variables separated on each side, okay? Like all the y's are going to go over here and live with mom now, and all the x's are going to live over here with dad, okay? Separate the variables. Oh, too soon, right? Sorry, my parents divorced in 1982, 83, and I'm still dealing with it. So when you integrate both sides, this becomes the ln, and it's kind of tricky because it would technically require a u substitution. You would let u be 6 minus y. Du would be negative dy. You would divide the negative sign over so that dy is negative du. And then the integral of du over u is the ln of u, so it's negative ln, absolute value of 6 minus y. Okay. I show, like I said, every step here. I divided this negative sign over. That was my first step. Notice if you take a plus c and divide it by a negative, it's still plus c because it was a constant that I didn't know to begin with. So when you divide it by a negative, it's still constant that I don't know. Maybe c was negative to begin with, and when I divide by a negative, it becomes positive. It doesn't matter. It doesn't matter about changing the sign on c. You don't want to change it. Just leave it as a plus c. Now I loop-de-loop it. This is loop-de-loops from here to here, right? That's how I get this equation. And then I have to solve for y. How do you solve for y? Well, I'm going to notice I brought the c down, e to the c. I showed all the steps here. The AP exam, they kind of expect you to go from the integrals to this to that. Like they don't show any steps. They just go boom, boom, You can show all the steps you need to get there. And so the general solution is 6 minus c e to the negative 1/3 x cubed. Then you plug in the point, which they give you the point up here. Remember the initial condition is f of negative 1 equal 2 or negative 1 comma 2. So I plug 2 in for y, plug negative 1 in for x. I can solve for c because I subtract 6, divide by negative e to the 1/3, and I get 4 over e to the 1/3. That is c. I'm going to put that into my equation, and right there I can be finished. Matter of fact, I had stopped right there. You can almost tell that between these steps and these steps, the blue pen became a more narrow, point, because I had written all of this, and then I looked at their answer key. They did not stop where I did. I stopped right here, and that's good enough to stop there. That is the particular solution to the difference equation. You solve for C, you plugged it back in, you have the equation for what y equals. But notice on their answer key, so I thought if any of you guys look at my 2009, number 4, their answer key is way down here. So they do a whole bunch more algebra, and of course they don't show any of it. Just give you that answer. They go from here to there. And they just go boom, boom. Here's the answer, morons. You know. So that was C, and then we jumped to 2009, number 5. So I did 2 questions off of 2009. Back in 09, who was there in 09? I really don't remember 09 much. I remember my senior aides because they were cool. Who was in the calculus class? I don't know. They don't matter. But anyway, 2009, number 5, BC calculus, FRQ was a table. So on this homework assignment, questions 3 and 4 were both tables. So I thought that would be good. Questions 1 and 2 here were both differential equations. So I was trying to pick a theme. And this is what's sort of unfortunate about this whole, like, not being at school. There's a lot of things that are unfortunate. But for us in math class, what I would normally do once we get through the content, we come back from spring break, I would do FRQs in class, and I would do like this number 3 in class, and then I'd give you number 4 for homework because they're very similar. Or I would have done number 1 in class and given you, I might have done number 2 in class because it was more complicated because you had to the x squared, you know? But number 1 and number 2 on this assignment were pretty much the same kind of equation. They both had Euler's method. One of them had Taylor polynomial, but the other one didn't. But still, so we would practice this in class, and in class we can kind of go through it together and get used to how the free response questions work, because that's something we have not done. And I every year I wish, I'd be better at integrating free response questions throughout the year, because the free response questions look very different than the actual Dr. Larson questions. And so I'm sorry, I've never done this in whatever 15 years. I never work in the free response questions. I just wait till the end and I just like cram them all in like the 3 weeks before the test, or 2 weeks before the test, depending on how much time we have, or 4 weeks before the test. Some years are better than others. So now we're practicing free response questions, and you might think, I don't know how to do any of this, but I promise you guys do. We just need to get through the shock of it. And once we keep practicing them, you'll see how it's the same questions over and over and over and over. They ask you the same questions. Okay, you're going to be able to do it, I promise. F prime of 4. How do you do F prime of 4? Notice this table is not F prime, it's F of X. You have to pay attention to that. Sometimes the table has F prime in it, like the free response question I gave you like 2 weeks ago. Not last week, but the week before that, I think. I don't know, whenever that was. It was the ones from 2012, before we even did Euler's method. So if you're asked to find the derivative, F prime of X, right? F prime of 4, that means the slope at 4. And when you look at this table, you don't use power rule or product rule or quotient rule because you don't have the function. You only have the table. So how do you find slope from a table? We've done this. You just do regular, good old-fashioned slope. That's just slope from 3 to 5, because 4 is between 3 and 5. Okay? So if they'd ask you to find the slope at 3.5, you'd have the same answer. If they'd asked you to find the slope at 4.9, you'd have the same answer, because all those numbers are between 3 and 5. If they asked you to find the slope at 3, change this f prime of 4 to a 3, the answer would still be -3. Same answer. If they ask you to find f prime at 5, then you would go from 5 to 8. Okay? Which happens later. But f prime of 4. So this is like, and this was worth 1 point, part A. This is 1 point everybody can get. You did this in middle school. Okay? y2 minus y1 over x2 minus x1. The tricky thing is not screwing up the negative signs and all that. So you do have -2 minus 4, which is negative. 5 minus 3 is positive. -6 divided by 2 is -3. Evaluate the integral from 2 to 13 of, and they just gave you a function here, a formula, 3 minus 5 f prime. Okay, so at first you might think, I have no idea how to do this. The table has f's in it, f's, not f primes. So first step I suggest is write out what this means. Okay, you know this means I'm going to integrate from 2 to 13 the number 3, which is power rule. You actually physically integrate that. Let's get it one time. Whoop, whoop. Let me hear you say the whoop, whoop. Can I get it one time? Whoop, raise it with the whoop, whoop. Raise the window, whoop, whoop, window, whoop. 20 minutes. Tack on it, Marty. I'm almost there. I don't know if anybody's watching these or not. I might be talking to myself. We're in conversation anyway. Luke, we're having company. Integrate 3 from 2 to 13 minus 5, the integral of 5f prime. And what happens when you integrate f prime? What is the integral of f prime? The integral of f prime is f. Integrate the derivative, you get the function. So this right here does come from the table. This is going to be f prime, integral of f prime is f of 13 minus f of 2, because the limits of integration are 2 to 13. Boom, boom, boom. Okay, the first part is the integral of 3. The integral of 3 is 3x. So they're actually having you do a very simple definite integral. This right here in this box. That'd be great if this was the whole question. If we could just like all this. Like, man, I passed this YIPPEE exam, man. It was easy. But they just put this super duper easy part in the middle of a bigger thing. And I don't know that you get any sort of point just for having 33. That part is 33, right? It's the area underneath a horizontal line, y equals 3 from 2 to 13. And 13 minus 2 is 11, and 11 times 3 is 33. That area would be 33. You get 39 minus 6, which is 33, right? Now, minus 5 integral from 2 to 13, the integral of f prime is f of 13 minus f of 2. So this is like calculus algebra, right? I'm writing the equation out, what it means, which is algebra, right? But it's a calculus equation. And so you end up getting 8. Works out really nice. Again, no calculator. I picked only problems that were no calculator. Part C. Left Riemann sum. So when there's a table, you're probably going to see a Riemann sum. What does Riemann sum mean? Remember, it was George Friedrich Bernhard Riemann. And he wrote the sum as, I don't know, n goes from 0 to infinity of f of x sub n times delta x, all that crazy stuff. All that crap really means, okay, Riemann sum. It means length times width, length times width, length times width, length times width. And it's funny that I said length times width because as I wrote base times height, base times height, base times height, base times height. So draw your butts, right? You put your parentheses, right? Parentheses, 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 because it says, well, it doesn't say 4. So that's the tricky thing here. You have to know that you're going to use 4. Why 4? Because it says subintervals indicated by the data in the table. You're forced to use this table. I copied the table from above down below. So I'm going to go from 2 to 3, from 3 to 5, from 5 to 8, 8 to 13 is 4 subintervals. Okay, so in Dr. Larson's book, he would say use 4 rectangles, right? Find the Riemann sum, or find the lower sum, or find the left sum. Find the left sum using n equals 4, right? That's what Larson does. His book is very different than this test. So notice my base or my width is x minus x. It's delta x. The height is y. In this case, it's the height on the left side. So again, when I think about the interval from 2 to 3, what number's on the left? Right? The left is at 2. So I try to color coordinate this here with the green, the purple, brown, and the fuchsia, the pink. So you get 18. 18 is the Riemann sum. Cool. What does that mean? I don't know. It doesn't matter. They ask you, I think, in the next problem what it means after you do the Riemann sum. Part D. All right, this is cool. I really like this problem. This is some fun math. This is at the same time math that you could argue, yo, bro, you never taught us this. We haven't done this before. And you're totally right. We have not explicitly done this, what you see on the screen right here. We've done all the math, but it's the analysis behind it. So both of these table questions, this question number 3 from 2009 and number 5, and then the example 4 that I gave you on this assignment, both ask you about overestimates or underestimates, or is the answer greater than or is it less than? Notice on this question, 2009, number 5, they actually use symbols less than or equal to 4, greater than or equal to 4/3. When we get to the next question, the last one, they use the words. They use greater, is it greater than or less than? Sometimes they use the word, is it an overestimate or is it an underestimate? So an overestimate means you did too much, right? It's greater than the actual answer. So understand that, like, explaining all these words down here in red, that's important. That's going to get you full points. But there's still points assigned to doing just this first part that's in the brown and the orange. Go Colts. I did that for my wife. She was in the room earlier when I was working these out. I was like, look, baby, I'm using details colors for you. So the first question says to use a line tangent to the graph of f at x equals 5. And they tell you that f prime of 5 is 3. Okay, cool. So what are the two things you have to find a line tangent? Guys, on this AP exam coming up, there will be at least one question where they ask you to find a line tangent. Okay, there's going to be one, at least one, probably only one. What do you have to write a tangent line or a line tangent or a linear equation? Is a point and a slope, point and a slope, a point and a slope, point and a slope, since like forever, point and a slope. If you get 1 point on this whole exam, please be on the equation of the tangent line. Okay, so the point is 5, -2. The slope is 3. How do you know that? So the slope is given right here. F prime of 5 is 3. And then they say at x equals 5. And from the table, did I erase everything? At x equals 5, y is -2. So that's how you know. You have the point from the table, you have the slope because they tell you. So the equation of line is y minus y equals the slope times x minus x. And they want you to show, right, that f of 7 is less than or equal to 4. So they're not very explicit in that they're wanting you to plug in 7 for x. So I plug 7 in for x and I get y equals 4. So that's the tangent line. And I didn't draw a picture here. I should have drawn a picture. That's the tangent line. So something true about tangent line, and then something else they said, which is boxed in red. Since it's in red, that's why I wrote all the answers in red. They tell you that the second derivative is less than 0. So if the second derivative is less than 0, what does that mean? That means that the graph is concave down. Since f prime prime is less than 0, f is concave down. F prime prime is less than 0. They tell you that. So this is important. Like, you have to use that piece of information. If they give you any sort of piece of information, it's useful for some reason. So I made a big bowl of ice cream. I brought it up here, started the video, and now the ice cream is melted. So now I'm gonna drink my ice cream. I'm an idiot. So the fact that the graph is concave down, that means the tangent lines are gonna sit above the graph. If the graph is ever concave down, the tangent lines sit above it. If the graph is concave up, the tangent lines would sit below it. So since the second derivative is negative, the graph is concave down, that means the tangent line above the graph. That means this value that I got from the tangent line, right? Tangent line's value at 7 is going to be bigger than the function's actual value. Maybe if I draw the picture a little bit better. So imagine I just drew this one tangent line, right? And I use the tangent line over here at 7. So the tangent line's at 5. That's the point of tangencies at 5, -2. So my graph is not drawing good. It should be below the x-axis. Oh well. This is 7 over here, right? Notice the blue dot of the red curve, right? The blue dot is greater than. That means the actual function's value, f of 7, come on, there it goes. F of 7 would be less than 4. It has to be less than the tangent line value. Okay. Then they ask you in, I kind of like to keep that there, but it's not really going to be right. In the other part, use the secant line. Okay, secant line, guys, is not tangent line. Secant line means you have 2 points. It means you have the starting point and a stopping point. And for this interval, the starting point is 5. The stopping point is 8. So they want you to find the slope between 5 and 8. The slope from 5 to 8 is 5/3. So that's what's in blue here. Okay. That's just from the table. That's the secant line slope. So what's the equation of the secant line? You use the same point, 5, -2, and you would get 5y plus 2 because it's y minus y equals the slope times x minus x. And I'm plugging 7. When you plug in 7 there for that equation, you add the 2 over. So that's I have a minus 2 here. I would subtract the 2 over, sorry. And then 7 minus 5 is 2. 2 times 5 thirds, 10 thirds. 10 thirds minus 2 is the same thing as 10 thirds minus 6 thirds, because 6 thirds is 2. 10 minus 6 is 4 thirds. So 4 thirds is the value of y on the secant line. So as I was saying a second ago, I didn't draw the graph very well, but imagine the secant line goes from here to here, right? So the secant line is the green one. I wish I'd drawn this picture ahead of time. Sorry. Dang it. Is he ever going to make a video less than 30 minutes? A punk. So on this green line over here on the left side, right? At 7, the dot at 7 is going to be green. Green line, green dot. But notice the green dot is below the red dot. Or another way to say it is that the red dot would be above the green dot. Martin. So over here I have, since f is concave down, the secant line sits below f of x. Therefore, f of 7 is going to be greater than 4 thirds. So the green dot on this line segment is at 4 thirds. The red dot would have to be above it. So I know that between the secant line and the tangent line is the actual function's value, which kind of gets into like mean value theorem and all that, but we don't really need that here. So anywho, 2007. So I went from 2009 to 2007. I do remember 2007. My brother Michael Quirk was a class of 2007. He didn't take BC calculus. We would not have gotten along very well in class. We would have butted heads for sure. But he played football, and so did Ben Rupp. Ben Rupp graduated class of 2007. Back in the O's, we used to go like 01, 02. That was always the thing at the pep rallies. We used to have pep rallies back then. And then we used to have school back then too. and anyway, 07, Ben Rupp, he was in BC calculus. And Ben Rupp is now an engineer in Kentucky. He actually worked kind of somewhere between Louisville and Cincinnati, like kind of like a not a very urban area, rural area, in like a steel factory. There's like a steel factory. I saw him, talk to him once. He got his degree at UK, pretty sure, engineering degree. Been up to OG. Dude was like national merit, and he played football, and he was a wrestler. So he was like a big dude, strong, and was super genius, super smart. Me, my melted ice cream. Oh well. So Ben Rupp took this question right here, and he was mad at me probably. Probably didn't prepare him good enough. But this table is different than the last one. Notice in this table, R prime is not the same as R. It's R prime. So this table is a table of rates, like the free response question from 2012 that I gave you guys. 012 that I gave you guys, 2 weeks ago. But again, first step, use a tangent line. So when you see tangent line, tell yourself, I need a point and a slope. I need a point and a slope. And it says use a tangent line at t equals 5. So at that point, you got to go, okay, I have to know the point at t equals 5. And it's up in all these words. So I can see how all these words are very frustrating. Notice I underline the graph of r is concave down. That's important to know right here. Okay. But also way over here, it says the radius of the balloon is 30 feet when t is 5. So that's my point of tangency. And then what is the slope when t is 5? Well, that's in the table. So I circled that with the green box and drew the 2 down. So the equation line, I didn't use y and x this time, I used r and t. And they want you to estimate the radius of the balloon using the tangent line approximation. And they want you to give, so notice it didn't ask this time for the equation of the tangent line, which kind of sucks. So if you were to write that out, you wouldn't get a point. The point comes from the 30.8. The other point comes from this answer down here in orange, right? From knowing all the words. So on an AP calculus test, when it says give a reason or justify your answer or explain your reasoning, that definitely means to write a sentence, which is something we have not done in class, because I put off all the free response questions. I mean, I do that on purpose. So up here, I had to explain it, right? on this last question, it says show that. So show that you know, explain your reasoning, show your work. Sometimes they say show your work. Um, so what is the reasoning here? I know that the radius at 5.4 is 30.8 feet. And that comes from the tangent line. So I do 5.4. Notice this is no calculator. 5.4 minus 5 is 0.4. 0.4 times 2 is 0.8. 0.8 plus 30, 30.8. Now, because r is concave down, they tell you the graph of r is concave down. The tangent line will sit above it. So this is very much like from the 2009 test, 2009 test, the graph I had before. When the graph's concave down, the tangent line is going to sit above it. So your point of tangency, right, is here at 5, but we're approximating the function's value at 5.4. The 5.4 is later. This is 5.4 right here, at 5.4. So at 5.4, the line's going to sit above the curve. So this 30.8 is an overestimate, or it's greater than the true value of the function, because the function is the curvy part. So concave down, you're going to have overestimates or greater thans. Concave up, it'll be underestimates or less thans. And we have not done that before, right? This was like stuff that I was going to still get to, and now I don't get to do it with you. I get to like do this from afar, sitting in my bedroom. My bedroom is kind of turned into my little, desk space. You guys have to hate this. I'm sorry. I told myself I was going to do this like fast, like 10, 15 minutes. The rate of change of the volume, related rates. We haven't done this in a while, as Don McLean would say, long, long time ago, or as Weird Al would say, long, long time ago. The rate of change of volume, that means the change of volume over time. That means dv dt or v prime of t. You can even call it v prime of t, but when it comes to related rates, we usually use the fraction notation, dr dt, dv dt. And so what is the derivative? I just dropped the tablet. Oops. That'd have been funny if it was on the video camera. The derivative of 4/3 pi r cubed is you do 3 times 4/3, which is 4 pi r squared dr dt, the derivative of r, right? Because of implicit differentiation, you got to multiply by r prime. Okay. From the table, r prime of 5 is 2, or you know that dr dt at 5 is 2. So again, you're getting this 2 from the table, this green 2. The 30 came from our point at the top. Remember, at time 5, r was 30. So I'm using, they don't repeat that here. They tell you at time 5, but you have to go hunting for the r being 30 right here. The math again is this year with a calculator. Back then in 2007, you couldn't use a calculator. So 3 times 3 is 9. 9 times 8 is 72. 72 times 00 is 7200 pi. And then it does say indicate units of measure, which is the first time we've had that on one of these questions. If they say indicate units, you will lose a point for not doing units. If you have no idea how to do this problem, but you know something about volume and change, you know that volume is units cubed. So you go back and you look at the units. Oh, it's feet, and cubed is feet cubed, and the time is per minute. So I think if you just make up an answer, but you put the units on both parts B and C, because part C also asks for units, you would get the unit point. So this problem was 9 points, but 1 point was just assigned to units. So think about units. You know how those work. Okay, Riemann sum again, just like on the last. So whenever there's a table, you're probably going to have a Riemann sum question. Notice the difference is in the last problem, the table was f of x. This table is r prime. So when you integrate r prime, you get r of x, or in this case, r of t. You get the function. So they want you to find the Riemann sum, but then they want you to explain what it means, okay? And they want you to use units. You got to look for that word units. See this word units? It's important. So again, the Riemann sum, right Riemann sum with 5 subintervals indicated by the data in the table. So when you have to use the table, you're not going to have equal widths. You have to use the table. So from 0 to 2, that's 2. From 2 to 5, that's 3. So the subintervals, the rectangles, are indicated by the table. So I didn't circle everything with the pretty colors and try to coordinate it. I just worked it out at this point. So, and it says right Riemann sum. Since it's right, you're going to use the number. So from 0 to 2, the number on the right is 4. Make sense? And then from 2 to 5, the number on the right is 20. Sorry, it's 2.0. 2. Man, my eyes is not working. So there's the answer, 19.3. What does this mean? So remember what it means to integrate. When you integrate r prime, you get r. Again, you should know the units because we're integrating feet per minute. So remember, you're going up a level. So feet per minute, your derivative. If you go up a level, you're going to have feet. Okay, so feet. Because this right here, this 2 to 0 is actually that's the width is the time in minutes. So that's 2 minutes. If you look at the units, that's 2 minutes. This 4 is 4 feet per minute, right? So when I do 2 minutes times 4 feet per minute, the minutes cancel and I'm left with 8 feet. So that's 8 feet, change in radius. But I'm not stopping at 2. I keep going. So from 0 to 2, if I change this to 0 to 2 instead of 12, that 8 is the change in the radius. Remember, what's happening is, I didn't really read the problem because all the words, and I don't do good with words. There's a balloon. It's being filled with, helium, gas, fire, right? It expands. The balloon grows. So it's expanding. It's changing its radius. The balloon is in the perfect shape of a sphere. So that's why we had the formula for a sphere earlier. And so the integral from 0 to 12 represents the change in radius. From 0 minutes to 12 minutes, the radius changed 19.3 feet. Holy mackerel. It's like, as tall as your house. Well, maybe not your house. Tall as my house. My house is only 20 feet. Your house is only 20 feet tall. It's pathetic, okay? My house goes 40 feet, okay? Ew. Anyway, just kidding. And then part D, finally, last part. Is your answer from part C greater than or less than the actual integral? The actual integral. This is some deep stuff. Because what's really, really important here is the fact that r prime is decreasing. Concave down is not really even important. I wrote that because they tell you in the very beginning, concave down. But remember, let's go back to this table. R prime. What is R prime doing? R prime, it was 5.7. Now it's 4.0. Now it's 2.0. Now it's 1.2. Now it's 0.6. You should notice, what are those numbers doing? Yes, as Robert Plant would say, going down now, going down, going to Chicago, going to Chicago. So the derivative is decreasing. The derivative is going down. R prime is decreasing. If the derivative is decreasing, that means the tangent lines are all negative, right? They're going down. Okay. If you use a right-sided Riemann sum, the right corner of the rectangle is going to hit the curve first, and then you go over, meaning the rectangles are going to be below the curve. The rectangles are below the curve. And this would also be true if r was concave up. So concave up and decreasing looks like this. It's still decreasing, right? Still decreasing. So it's mostly about the decreasing. You have to say r prime is decreasing. And that's tricky, okay? Because that means you really, really, really have a strong understanding of what's happening. And some of you guys are like, I don't even know where I am right now. Like, am I in my room? I know you're not in room 203 at Eastern High School. I don't know where you are either. But r prime is decreasing is very important. So if the graph's going down, whether it's concave up or concave down, the right-sided rectangles are going to be below the curve. Okay, so when I did my Riemann sum, remember the Riemann sum was a way to approximate the integral from 0 to 12. So when I approximated the integral, it's not correct. It's an approximation. So the approximation will be less than the actual integral, because the actual integral would include all these like little bits that we left out. So our actual answer would be more. So the approximation in part C is less than the actual integral. And you have to give an answer. So if you just said less than, because you got a 50-50 chance, right? I'm not sure, is it greater than or less than? I'm gonna guess less than. I think this question is worth 2 points. I actually have it over here. Where is it? because I checked all of these. That was the other one. Notice, no, it's only worth 1 point, and it's conclusion with reason. So if you just guess like less than, but you don't have a reason that's valid, you won't get that 1 point. Notice that down here is what I was saying. There's a 1 unit, there's a point, 1 point for units in B and C. So if you left the units off, if you left it off of B, but you put the units on C, you would not get that 1 point. So I think if you actually make up an answer for B and C and put a unit next to them, and the units are correct, you would get your unit point. Okay, that's tricky. Again, we're gonna practice this more and more and more and more and more. We're gonna practice. Practice? Yeah, we're talking about practice. All right, I'm gonna let you go. 45 minutes. God bless America. Land that I love, some cider and guide